In this video, we will see that how we can parameterize a Steel I-Girder section in the user section mode of CIM.
And now we will try to get the parameterization done for the Steel I-Girder. We have already defined the Steel I-Girder section. We'll go to it. So over here, we will be using the coincident type of constraint for locking all the vertices of this Steel I-Girder section. Apart from that, we will be choosing the fixed constraint over here at the reference location. And in the dimension line, we will be using the horizontal and vertical dimensions only. So now let us first define the reference lines. So at the top mid location of the flange, we will be defining one reference line, and same we will be having the at the bottom mid location. Now we need to define one constraint line over here and over here as well. So what we'll do, we will just place a reference line over here, and in the x direction we'll assign the value as 0 millimeters. So it will get automatically shifted to the center location. And now we'll click on blue plus. Same we'll assign for the bottom. We'll change the x direction value as 0 millimeters, and we'll click on green tick. Now we'll go to the constraint part. We'll assign the fixed constraint at the top location. And since we know that we will be using the coincident or constraint options only, then we will be directly choosing this edge, and will be coinciding the vertices with this edge. Same for the second reference line and the edges. So over here we are having 4 vertices. One is over here, second, third, and the fourth. All these vertices will be moved wherever the reference line is getting moved. Same way, the third constraint point, the third reference line, and the fourth reference line. Now we have defined the reference line and the constraint points. Now let's define the dimensions. So first of all, we will define the vertical. So now first of all, we will select this reference line and this reference line. So we got a preview over here, which is 35 mm wide. So this will be the top flange height of the steel girder. Now let's define the height of the wave. So we will be choosing the second reference line and the third reference line over here. We'll click on blue plus, and similarly for the bottom flange height, we'll be choosing third and the fourth reference lines. Now we will define the horizontal dimensions. So first of all, in the top flange, we will be having this vertex, and we will refer to the reference location. We'll click on blue plus. Similarly with the reference location to the end of the top flange part. Now we will be defining the thickness of web, and for that we will be choosing this edge and this reference point location. So currently the half of the wave thickness is 16 millimeters. Similarly, we will be choosing this vertices, this vertex and this reference location. And at the bottom flange, we'll be choosing this vertex and this reference location. Click on blue plus. Same way, we will be choosing the bottom right corner of the steel girder and the reference location, the datum location, and we'll click on blue plus to assign the dimension lines. Now we are completed with the definition of constraint, dimension lines, and the reference lines. Now let us go to the parameter and click on edit. Now let's define the length type parameter. So we will be having top flange width, let us assign the variable name as TFW, in which the T will be in capital and F and W will be in the smaller cases. The dimension is 800 millimeters. Bottom flange width PFW with a dimension of 900 millimeters. Wave thickness TW 32 millimeters. Top flange thickness, which is TFW, it is around 35 millimeters. Top flange thickness PF 35 millimeters. Bottom flange thickness 40 millimeters. And the last, height of wave HW, which is 1500 millimeters. Now since our dimensions are in parts, so we need to again define the equation part. So the half top length, half top flange width, check on this option. We'll assign the equation as T FW divided by 2. Next, half bottom flange width. We'll assign the equation as capital P small fw divided by 2, and the half wave thickness. So it will be TW divided by 2. Now we'll click on green tick. Again, we will link the parameters with the dimension lines. So over here, H7 and H8 will be assigned for the half top flange width. The H9 and H10 are for the half wave thicknesses. Same with H11 and H12. We'll be defining with the half bottom flange width. And for V4, we'll assign the parameter as top flange thickness. For V5, we'll assign the height of wave. And for V6, we will define the bottom flange thickness. Now we'll press green tick to apply the changes. Now let's go to parameter and we will edit some parameters. Like, let's say I want to change the top flange width from 800 to 1000 millimeters. I'll click on blue plus. So automatically it got updated. Now let us change the wave thickness from 32 to 28 millimeters. We'll click on blue plus. So automatically you can see the 14 is visible over here. Let us change it to 50. So it got updated to 25. We are having two dimension lines over there, but due to the congestion, it is overlapping each other. Now at the last, let's change the height of wave from 1500 to 2500 millimeters. Click on blue plus. We close it. So you can see the height of wave is changed. Similarly, we can resize the section as per our requirement using the parameters option. Now we'll click on green tick at the top of model window. We'll go back to point library mode